My dear students, wish you all happy new year. In this new year, I am going to start one important topic of video lecture, that is block diagram reduction technique. So today's video is the block diagram reduction technique, that is introduction to block diagram reduction technique. So generally the block diagram is used to represent a system in mathematical modeling of physical system. So the block diagram technique is used to represent a control system in the mathematical modeling of physical system, and it is also a graphical technique. So generally this block diagram establishes a relationship between different components. For example, in a physical system there are so many types of component: inductor, resistor, capacitor, transistor, etc. And the block diagram establishes the relationship between different components and also defines the function of each component. So block diagram establishes a relationship between different components and also defines the function of each components. And generally this block diagram is used, it is best suitable for linear time invariant systems. So what is linear time invariant system? Already I have discussed in my last lecture. So here there is no need to explain again, and it is also it is also best suitable, it is best suitable for single input and single output system. But it is having a major disadvantage that it is not unique. This technique is not unique. It means for same mathematical modeling we can have different block diagram reduction technique. Therefore, this technique is not unique. It will differ from one model to other. So, and there is no definite starting point. Again, for each step we have to draw one block diagram. Therefore, it can take very large time to solve any control problem, and also it is applicable to single input and single output system. So generally it consists of 4 basic elements. It consists of 4 basic elements, or you can say 4 basic blocks. That is, one is called block, second is summing point or summer, and third is pickup point or takeoff point. And fourth is arrow. So one by one I will discuss. So let us first know about the blocks. So what is called a block? So block is nothing but it represents the different components, that is either it may be resistor, inductor or capacitor. By one block it is having one input, and this is the input of this block, and this is the output of these blocks. So it may be one inductor, capacitor, resistor, etc. So the different components are represented by one block. Then next we will discuss about the summing point. Or summer. So this is called the summing point, or it is called summer. So this is one input, this is another input, this is another input. So we can take here minus, also we can take here minus. It may be this may be plus, this may be minus, this may be plus. So sign will be changed according to the direction of signal. So let us assume that this is your P, Q, and this is R, and this is the output S. So one summing point or summer having minimum 3 inputs and 1 output, and generally it does the arithmetic addition. It does the function of arithmetic addition or subtraction, and generally it is nothing but a comparator circuit. It can compare the input with the feedback signal and produces an error signal. So sorry for interruption. So this is your summer or summing point. Next we will discuss about the takeoff point. Takeoff point in the, this is called one takeoff point. This is the takeoff point. Takeoff point. So let us assume that this is the signal P and this also signal. So in the takeoff point where the signal flows in various directions, so if this signal will be P, so here P will flow, here also P will flow. So signal flows in a various direction from the takeoff point. So next we will see the arrow. This is the arrow. This indicates the direction of signal. This indicates the direction of signal. So by taking these 4 basic blocks, we can draw a block diagram of a control system. So now let us discuss about the feedback system. So here the system is called in canonical form, that is, if this is the forward path transfer function, or it is called open loop transfer function, having one feedback path transfer function. So here GS is called forward path transfer function, HS is called feedback path transfer function, and BS is called feedback signal, and ES is called error signal, and RS is called reference signal, and CS is called controlled output. Therefore, if it is having the negative feedback, then it is called, this system of feedback is called canonical form. This is called canonical form. Therefore, the transfer function CS by RS is equal to G of S by 1 plus G of S and H of S. So now we can prove this. The transfer function of a negative feedback system, that is in canonical form, so is equal to G of S by 1 plus G of SH, sorry, GS by 1 plus G of S and H of S. So let us find the transfer function. So here E of S is equal to R of S minus B of S. This will be plus R of S minus R of B of S. That is the error signal. So next we can find out. So B of S is equal to C of S into H of S, and next we can find out what is C of S. C of S is equal to E of S into G of S. So now we can put here in place of E of S, so we can put here, that is R of S minus B of, so minus B of S into G of S. So in place of E of S, I have put it here R of S minus B of S into G of S. So now in place of B of S, I can put this, that is C of S into H of S. So now the C of S is equal to R of S into G of S minus G of S into, in place of B of S, we can put here C of S, H of S, C of S, H of S. So this implies thus C of S is equal to, sorry, you can take common here, C of S plus G of S, H of S, C of S is equal to R of S, G of S. So take common C of S, that is 1 plus G of S, H of S is equal to R of S into G of S. So transfer function C of S by R of S is equal to G of S by 1 plus G of S into H of S, where so it is proved that for a canonical form of feedback system, the transfer function C of S by R of S, G of S by 1 plus G of S, H of S, whereas G of S is called forward path transfer function, and H of S is equal to feedback path transfer function, and B of S is equal to feedback signal, and E of S is equal to error signal, and R of S is equal to input signal. So thank you very much.